In the previous video, we looked at ionic bonds, and something I did not mention that is important is the word transferred. Ionic bonds are created when an electron, or more than one electron, is transferred from one atom to another, creating the ions. In covalent bonds, which is the topic of the first part of this video, there is no transferring of electrons, so ions are not created. With covalent bonds, the key word is sharing. Electrons are shared in covalent bonds. So look at hydrogen here. There's two hydrogen. The atomic number of hydrogen is 1. So there is one proton in the nucleus and one electron flying around this hydrogen. How many hydrogens, or how many electrons, does the first shell want according to the octet rule? Well, 2. So this hydrogen is in the same boat. It wants another electron as well, because it only has one electron. So these hydrogens can share their electrons. Now both hydrogens have 2 electrons, which meets the octet rule. The first shell would like 2 electrons. That's a covalent bond. Co meaning sharing, valent, valence electrons, outer shell electrons. Hydrogen only happens to have one shell, so therefore it would be the valence shell. And you can see here, carbon and oxygens are sharing electrons to meet their octet rules. 2 oxygens are sharing electrons to meet their octet rules of 8 in this valence shell. Nitrogens are sharing a lot of electrons here in order to meet their octet rule requirements. So these are all covalent bonds where electrons are being shared. Covalent bonds are extremely strong bonds. They will not break apart in solution like ionic bonds do. One more important piece of information on this slide is these covalent bonds that you see are nonpolar, meaning the sharing is equal between the atoms. When you have equal sharing, there's no weak charges created across the molecule. That might not make a whole lot of sense right now, but let's go to the next slide and look at polar covalent bonds so we can see the difference. Here's water, H2O. Here's the O oxygen. Here are the H's, hydrogens. This molecule is sharing electrons, making it a covalent bond. But when you have one atom with a lot of protons compared to the other atoms, in this case oxygen has 8 protons versus 1 each for the hydrogens, well then you have unequal sharing of electrons. Protons are positively charged, so they're going to attract the negatively charged electrons. Remember, electrons are flying around these shells very fast. At any given point in time, there's going to be more electrons favoring this side of the molecule, the oxygen side of the molecule, than there are on the hydrogen side of the molecule, making this end weakly negative. There's the little symbol for weakly, and this end of the molecule weakly positive. Now, the atoms themselves are not charged. They're not ions because they're still sharing electrons, they're just not sharing equally. So we create poles, P-O-L-E, poles, with a weakly negative side and a weakly positive side. So since there is an unequal sharing of electrons, these are polar covalent bonds. In the previous slide, there was equally shared electrons, so those are nonpolar covalent bonds. Here we see 3 water molecules. Recall from the previous slide, in a polar covalent bond dealing with water, the oxygen end is going to be weakly negative, the hydrogen end is going to be weakly positive. So what if we take the weakly negative end of one molecule and approximate it to the weakly positive end of another molecule, like right here and right here? Well, you have a bond created. But these are weak bonds, and they always will involve hydrogen, and we call them hydrogen bonds. Technically, they're not actually a bond, it's more of just an attraction, but we consider them bonds. So of the three types of bonds that we looked at, hydrogen bonds are the weakest. Covalent bonds, which involve sharing of electrons, are the strongest. Ionic bonds are in the middle because they break apart when they're put in solution. So here's water. Well, water has a surface. That's why this paper clip can float on top of it. Well, what if you drop a spoon in this water? It's not going to float, it's going to drop to the bottom because the spoon has enough mass to break these hydrogen bonds as it works its way down the cup.